Good morning, grade 5. How are you all? Today's date is the 14th of May 2020. The day is Thursday. We're going to be continuing with Unit 6, more about forces. The topic is what is weight. It's from your pupil's book, page 123 to 125, and the objective is to recognize that weight is a force that depends upon gravitational force. So let's review what we have done. Gravitational force or gravity is a force of attraction between two objects. Gravity depends upon the mass of the object and the distance between them. Objects fall to the ground towards the center because of the pulls of Earth's gravitational force. You can see the Earth here and you can see the direction of which the force is acting upon. Earth's gravity acts upon everything because Earth has a very big mass. Because we are very small as compared to the Earth, so we cannot exert any force on the Earth. The Earth pulls everything towards the center, and this is called as a gravitational force of the Earth. So what are we going to learn today? We're going to learn about weight. Place a heavy book on your hand, and can you feel the book pushing down on your hand? This pushing down force acting on your hand is the weight of the book. The weight of an object is the gravitational force acting upon it. That means the push that you're feeling is the gravitational force acting upon the book. We all know that objects in the world have mass. Everything has mass because matter has mass. The amount of matter in an object is called as mass. So weight is the gravitational pull acting on the mass of an object. Like in your case, in your hand, the book has a mass. It's being pulled by the gravity, and this pull of the gravity on that mass of your book is actually the weight of the book. Okay, and it is measured in newtons. The weight and it depends upon the gravitational force, and it is not the same like how we measure our weight on the scale. The weight we measure on the scale is kg, whereas the weight is actually a force. It is measured in newton. We know the Earth's gravity is stronger than the Moon's gravity. Why? Because the Earth is bigger in size than the Moon. It has more mass than the Moon. So the Moon's gravity, we have found out by the scientists, is that it's 1/6 of the Earth's gravity. So if an object like an astronaut with the same mass, that means his matter is not going to change when he will go into space, will weight differently on the Earth than it does on a Moon. For example, if we have an astronaut who weighs 120 kg on the Earth, even though the astronaut doesn't change in size or in mass, their weight would be on the Moon 20 kg. How? 120 kg divided by 6 will give you 20 kgs because Moon's gravity is 1/6 of the gravity of the Earth. So we are having maths also in science. What is the Moon's gravity? Moon's gravity is 1/6 meters per second square. What is the Earth's gravity? It is 9.8 meter per second square. Now I want you to open your pupil book page 124. You can see a picture there of an astronaut. He has landed on the Moon. Would he be able to jump higher, lower, or the same height as he does on the Earth? I want you to give me a reason also. Well, let's see. I'll tell you my answer. Let's see if yours is the same. The astronaut will be able to jump higher. This is because the Moon's gravitational force or Moon's gravity is weaker than the Earth. Because there is less force pulling the astronaut down, so he will be able to jump higher as compared to that on the Earth. Now, the next question. I think you must have read it by now. So I'll read it once again. Would the astronaut fall to the ground more quickly, less quickly, or just as quickly as compared to when he is on the Earth? And why? When he will jump and when he comes back, will he be able to fall as quickly he does on the earth, or less quickly than he does on the earth, or the same as the earth? What is the answer? Let's check. The astronaut will fall less quickly to the ground because the gravitational pull, as I told you before, is going to be less, and it's smaller on the moon than on the earth. So there is less force pulling him back. So he will come down slowly after he has jumped. When we jump on the earth, we forget that it's the gravity that makes us fall back. On the earth, we are used to knowing what jump is. But on the moon, because there's less gravitational force, people are jumping and they're coming back slower, as we discussed in the last slide. And this is why the astronauts who go there, they feel as if they're floating on the moon. See, we know that the earth has more mass as compared to the moon. But do you think, if we think about another planet, for example, Jupiter, how are you going to jump there? Jupiter is much, much larger than the earth. It has much, much more mass than the earth. So more mass, more gravitational force. And more gravitational force, do you think you will be able to jump on the Jupiter, whose gravity is around 24.8 meter per second square? You will find it very difficult. Why? Because there is more gravitational pull pulling you towards the center than allowing you to jump. And most importantly, we know that Jupiter is a gas giant, as we have learned earlier. So standing on Jupiter is almost impossible. But we are just considering, guessing, would you be able to jump on Jupiter, who has a gravitational force of 24.8? You would require a large amount of force. So the weight of an object, it depends upon the gravity. So the weight of an astronaut is going to be different, entirely different than the Earth and the Moon on Jupiter. It's going to be divided by the amount of matter is going to be divided by the Jupiter's gravity. So if, as we were discussing, the mass of an astronaut on Earth and the weight of the astronaut on Earth, it was 120 kg, right? The weight of an astronaut on Earth was 120 kg. What would be on Jupiter? It's going to be divided by 24.8 meter per second square. So it's going to be what? Find it out and tell me. Send it to me on your Horizon links on Communicate. Now we know weight is a force, so we have to measure it. Weight is measured by using a Newton meter. We can also call it as a force meter. Weight is a mass of an object. It is affected by how strong the gravity is. Weight is also a force. It's a force of a mass pushing down on the surface on which it is standing. So weight is measured in newtons. It is measured using a force meter or a Newton meter. You can see a Newton meter here. Okay, and you can see we have attached an apple to it, and it's not yet started to record its reading. So when you measure the weight in kilograms, did you know that you're actually measuring the kilogram by force, meaning mass multiplied by the force of gravity? So how does the force meter work? This is what you need to do. Since we are not in the school and because of the COVID-19, we cannot do this experiment, but I can show it to you how it actually works. There's a spring inside the force meter. The weight of an object stretches the spring and the pointer moves on the scale. The more the weight of an object, the further the pointer or the indicator will move. And we can read the weight from the scale of the force meter. Now, for example, it is shown here. The weight of an apple is 1 Newton. I want you to do a small experiment and I want you to give me some predictions. Okay? Just take 3 items, a coin, an apple, and your school bag. Okay? And put it on your hand one by one. Feel the force acting on them and predict their weight. Just guess. I mean, you to guess and predict which object is going to have the largest weight. Okay, I know it depends upon what you're choosing. It depends upon you're using an empty bag or a full bag. If you're using an empty bag, then you would see that the case is going to be different. When you're going to be using a bag full of books, it's going to be different because it's going to be having more mass. An empty bag is going to be having less mass. So which object has the largest weight? That you're going to tell me. And is largest force needed to lift that object? You would need more force to hold it in your hand, right? So I want you to tell me which object has the largest weight. Predict, guess, and then tell it to me again on Communicate on Horizon. Okay, and I hope you understood the lesson. It was not a lengthy one. It's about weight and how it is affected by the gravitational force. It depends upon the force of gravity. It is not mass, it's not in kg. Weight is measured in newtons. Mass is the amount of matter and weight is the force which acts on that matter. Okay. Now I want you to complete and copy the study link. Okay. Revise. It's going to give you some information about the topic that we're learning now. And I hope you stay at home, stay safe, and Ramadan Kareem to all of you. Goodbye.